Thank you for clicking on this Gergo Print 3D video. This channel is dedicated to 3D printing, and this time I'm going to show you a lot of different printing techniques on this colorful magnetic chess set in vase mode. Then we will prepare the print-in-place hinged chessboard for printing using multiple colors on the first layer without a dedicated multicolor printer. In fact, I'm using the Sovo SVO7 Plus running Clipper, and most of the magic is done using Orca Slicer. You will be surprised how many tricky techniques are involved in this little project. Starting by eliminating the seam lines using vase mode, working with dual color filaments, and the secret to achieving the shiniest polish on silk filament. Printing many vase mode objects in larger batches. Adjusting geometry to make parts printable in vase mode. And we haven't even got to the board yet. Here we will see how to design and print multicolor first layers using a single extruder printer without any multi-material hardware. And how to incorporate magnets in our prints. I'm going to show you all these today. If videos like this interest you, please consider subscribing to Gergo Print 3D. So, let's start with the pieces. I found this beautifully designed set on Thingiverse. What's special about them is that they can and are actually supposed to be printed in vase mode, which means each piece is printed in one go without lifting the nozzle, traveling in a continuous, seamless spiral path. This printing method limits the kind of geometry that can be printed. I think the most striking example is the knight in this set. To tell the truth, this was the piece that sold me on this set. Vase mode parts by nature are limited to a single wall and cannot have any infill either, which, in combination, results in extremely light pieces. They would fall over way too easily by themselves, so I decided to put magnets both in the pieces and in the board. We will need 96 of these tiny 4mm rare earth magnets. Fortunately, they are quite inexpensive at just $3-4 for 100 of these magnets. See the link to my AliExpress source in the description. We can increase the wall width by using a bigger nozzle, but I actually printed my first set using the standard 0.4mm nozzle and they turned out strong enough. I printed a second set using the 0.6mm nozzle on my SVO6 Plus. Both sets turned out great. To achieve this beautiful shiny dual color look, I used Sovo's orange blue and red blue dual silk PLAs. I can only recommend these high quality filaments. You will find links to them in the description as well. We can print multiple vase mode pieces if we set Orca Slicer to print by object instead of the default by layer option. We have to be very careful though the way we arrange the pieces on the build plate, so already printed pieces are not knocked over by the print head. You see, I add the pieces in the front of the build plate first, then continue in reverse order in the next row and so on. You can also reorder the pieces if you switch to object view here. The slicer has the dimensions of my printer's tool head and won't let me place objects too close to each other. The order of the pieces in the back row also need your attention. See, I made sure the last item printed in the back right corner is the tallest in that row. So at the end of the print, when the print head moves to its parking position in the back left corner, it will be high enough to pass over the other pieces in that row. Having a relatively large build surface printer lets me print 9 pieces in a go, which is a great convenience. The whole set can be printed in just 4 sessions. The speed settings you see here are a little misleading because I ended up slowing down the print by 50% on both printers to get this perfectly smooth and gleaming result. The higher the print speed, the more matte your parts will get. Before slicing though, I actually had to adjust the geometry of the pieces. First, the top part of the queen and the pawns had trouble printing. So I used Fusion 360 to stretch the top of the queen to make the roof steeper and hence more printable. I also added a 4.5mm hole for the magnet in the bottom of every piece in the set. In case of the pawn, I decided to stretch the whole piece, which is easy to do in Orca Slicer. Just remember to turn off uniform scaling. Magnetic force follows an inverse square law, which means that it decreases rapidly as the distance increases. In practice, we want the magnets in the board and in the pieces to be as close to each other as possible. I glued the magnets in a second set of bottoms, which have only a single layer, 0.2mm of filament, where the magnets go in the center, to have the minimum distance from the board. I included STLs for these bottoms with the updated pieces, also linked below in the description. I used super glue to hold the magnets and secure the bottoms to the pieces. Okay, we have the pieces. Now on to the board. I designed it from scratch in Fusion 360. It includes gaskets for 64 little magnets. We will pause the print and add the magnets before their little compartments are covered. I incorporated the print-in-place hinge from another box I found on Thingiverse. So the board is designed to print unfolded, the top place surface printed first, touching the build plate. This initial layer is separated by color into 3 parts: the orange-blue light squares, the blue-red dark squares, and the rainbow universe that I used for the rest of the box. Because it's a multi-part model, the file format is 3MF, not the usual STL. We might get a warning that this particular 3MF is not supported by Orca Slicer, loading geometry data only, which is not really a problem. It's what we expected. Yes, we want to load it as a single object with multiple parts to keep it together when we manipulate it in the slicer. Okay, we flip the top to face the build plate. Then comes the multicolor magic. In preparation, let's go to the printer profile and enable manual filament change under multi-material. Then make sure the filament change G-code is set to M600. Notice I commented out everything else that was in there. If you haven't added an M600 macro yet, please do it based on my earlier video on the M600 command. Otherwise, this won't work correctly. Finally, check if your pause G-code is correct. Sovol Clipper screens don't come with M601 defined. The macro here is simply called pause. That's the safest to use. Now we can select the filament we are using. In my case, it's Sovol's Silk PLA. Here you can pause to see my well-tested flow and cooling values if you want. Then we make 2 more copies of the filament using the plus sign over the selection. I bet you haven't noticed these little symbols up there. This is the first time I'm using them too. This way, we have 2 more colors we can assign to various objects in our print. So, we switch to Object View, and here I can change the dark squares to color 3 and the light squares to color 2, keeping color 1 for the rest of the board. Check the first layer of your sliced model. See how the printer is going to print the light squares first, then automatically pause for a filament change before printing the other frame, then issue an M600 again, and print the dark squares. Finally, it will pause one last time, letting us load the filament we use for the rest of the board. This is all done without any further setup. It's so great. There is one more pause, however, that we will have to add manually. When the little compartments for the magnets are all done printing, just before printing the covering layers, we want to pause the print. A side note, be sure to turn off supports for the whole print. Otherwise, these little caskets would be filled up and you would not be able to add the magnets. Supports need to be off for the print in place hinge as well, of course. So, here's the whole process in practice. Light squares are printed using the orange-blue filament. Here you can see I'm switching to the rainbow universe for the frame. Again, do watch my video on multicolor prints for a detailed explanation of the color swap process. At the next pause, I switch to the blue-red silk for the dark squares. Now we can go back to the rainbow universe, and that is going to be used for the rest of the print. The layer slider in Orca actually tells us the timestamp of the next pause command at 2 hours and 45 minutes. So now we can leave the printer to itself for a few hours. When it eventually pauses, I add the magnets. Notice how I double check the polarity of each magnet I drop in the little compartments. This backside of them should actually repel the bottom of the chess piece I'm using for testing. This way we can make sure the other game side will attract. This is very important, otherwise you can end up with squares on your board where you won't be able to place any chess piece. Those squares would repel the pieces. If you want to eliminate this possible fail point, I can understand you. You can decide to use M2 nuts instead of the magnets in the board. They are the same size. The magnetic attraction will be a bit weaker, though still sufficient in my test. But you won't need to worry about polarity. M2 nuts are also less expensive, so you'll only need 32 magnets only for the pieces. The end result is not only highly functional, but attractive as well, and not only because of the magnets, if you forgive the pun. These print techniques will come handy even if you don't print this exact chess game. Both you and your printer have gained new skills thanks to these additions. I hope I earned your like this time, and maybe even your subscription. Either way, thank you for staying all the way to the end. It's fun to watch, but now it's your turn. Create something amazing. Go print 3D.